In this portion of Chapter 12, we're going to be looking at the acid-catalyzed reaction of our alkenes for the electrophilic addition to those nonpolar pi bonds. So first acid-catalyzed reaction that we're going to look at is going to be the hydration of the alkene. So for the hydration of the alkene, we're going to add water across the alkene in the presence of a strong acid to end up forming our alcohol. So with this process, it is going to be very similar to what we saw with our strong acid reaction in the previous sections. But with this one, we're going to be adding water under our strong acid condition. So I'm just going to use H2SO4. I'm going to use H2SO4 as the strong acid because I don't want to have it be something nucleophilic. So we're going to stay away from using things like HCl or HBr because those would end up producing the nucleophilic compounds like we saw previously with the halide. So we still need to use strong acid conditions, so I'm going to use sulfuric acid. What we see under these water and strong acid condition is we do end up producing the alcohol. We're still going to follow all the same rules that we looked at previously. We're going to follow Markovnikov's rule in terms of the hydrogen addition and the second nucleophile addition. So it's still going to follow all the same guidelines that we looked at previously. Mechanistically, if we look at this reaction, since we're under strong aqueous acid conditions, we will start with that hydronium ion. It becomes the initial electrophile that will react with the alkene nucleophile, and we will still end up producing that intermediate carbocation. The intermediate carbocation that we are producing here is a tertiary carbocation, so there will be no other rearrangements that we have to worry about. From here, our new nucleophile of water can come in and attack our really good electrophile, which is the carbocation, to get us to another intermediate where the oxygen now has 3 bonds again and a positive charge with it. And we have formed the new bond between the oxygen and the carbon. Since these are acid catalyzed, remember a catalyst we have to get back in our reaction. So we will take another water molecule, and the water molecule will deprotonate that alcohol that we added. So we get back to the final alcohol that we wanted as our final product, and we also produced our acid again at the end of our reaction. So remember, catalyzed reactions, we do need to reproduce the catalyst at the end of our mechanism. So very similar to mechanism what we saw previously, just a change in what the second nucleophile will be that adds to the carbocation. We can also see acid catalyzed alkoxylation of alkenes as well. So in this process, we're now going to add an alcohol to the alkene in the presence of the strong acid catalyst. And this will end up producing the ether instead of the alcohol. So in this reaction, the only thing that we are going to change is going to be, instead of reacting it with water, we're going to be reacting it with an alcohol. We are still going to be under those strong acid catalyst conditions. So this time we end up adding the OR unit to the alkene instead of the OH unit. It is the exact same mechanism that you would walk through, and the only difference is we are generating the ether instead of generating the alcohol.